Hello everyone. So finally animated level parts with animation are implemented. That's right. We finally have a working animation system for Magicka. And let me just show you the results. So we'll talk about the implementation in a while, but first, well, of course, still as always my map is green because I keep forgetting to put in the path for my texture. But here it is. This object right here is going to start moving in a loop with a very simple animation where we just rotate upwards and then it will just repeat the animation, so we just pop back and do the thing, right? And it's going to be triggered when we enter our classic testing trigger area that we always have in here. So, and it's actually kind of synchronized with the clock sound in the background. But there it is, yeah. So finally we got working animated level parts. Well, it's very simple, it's kind of shitty, I haven't done anything interesting with it yet, but you can now make basically anything that you want. You could make doors, you can make levers, you can make platforms, you can make anything, right? And the collision support is also added, but I haven't tested it yet, so I don't know if it even works. We're going to find out in this video actually. So if we go over here to the text editor so I can showcase what is going on, this right here is where we've got the animated level parts, and we got this animated level part text. Whoops, I fucked up, sorry. So this right here has the model data, which I think we already explained in a previous video. If not, I can always make an overview covering how it works. We got the mesh settings going on, and we got all of this stuff in here, but here's where the important thing is, and that's the animation duration stuff and the animation keyframes. So the animation duration in this case is this long right here, okay? Hopefully it's calculated properly. The speed looks to be 100% correct to me actually, because the animation in Blender actually looks like that, I think. And the frames are just 2 frames, and it still smoothly lerps between them, so that's great because it means we don't need to waste information by baking tons of frames in between. We can use the same amount of frames we have in Blender, right? So the frames, as you can see, they contain the time at which they happen, and they contain the position, rotation, and scale, right? And that's pretty much all there is to it. The objects that don't have any animation need to have a dummy frame, quote unquote, right? Which would be an animation with duration 0 and only 1 frame, and the frame would be the exact same coordinates as the resting position of the object to be able to display it correctly. So I'm explaining this because I'm going to show the code in a while, but here we go. This right here is the object, which, as you can see, is named lever. So it was going to be a lever originally, but it's fucking nothing right now. It's more like a clock. As you can see, it's got a keyframe in Blender in 0, in the frame 0, and another one in frame 10, right? And this is what the animation looks like. Pretty much the same as in Blender. Sorry, as in, in Magicka. So that's what we got going. And the way it calculates the duration and absolutely everything is by taking the time that the entire animation is going to last, by picking the last frame and calculating the time in the last frame and subtracting the time in the first frame, right? So that means that it's actually a system implemented around the idea that the first frame is frame 0, even though a lot of systems work starting on frame 1 and others on frame 0. In this case, I had to make the compromise of starting at frame 0, but it doesn't matter. You can start at frame 1 if you want, right? You can actually start at frame 1 and the time is calculated correctly. The only thing is, I think that if we start in frame 1, you would have like 1 frame of worth of downtime where your animation would not start yet. So for some things it might not be a big deal. For some things that are more other things that are more timing sensitive, it might be important to actually stick to starting at frame 0. I personally like starting at frame 0, okay? But as you can see, Blender's timeline technically starts at 1. And you could also have negative frames if you want. I don't know why anyone would want to do that, but they would probably technically work because I've programmed everything accounting even for negative values. So yeah, basically you can put in anything you want, and if we want, we can make the animation more complex. We're gonna go ahead and change it up. Actually, we're going to make this thing, rather than rotate again, we're gonna make it move in this direction, and we're going to well, when we press K or I, you can just use I to insert the data that you have changed, or you can use K if you want more control to insert the kind of transform changes you want to insert, right? In case you only want to save the rotation or the location change or the scale, rather than saving all of the information on this keyframe, right? I mentioned this, it's very important because Magicka needs to store all of the data. So you would think that for things to work, you would have to always press location, rotation, and scale, but you don't have to do that, right? You can just save anything that you want. If you only save location, the way Blender works under the hood is that every single animation data has a set of actions, and every single action has a set of F-curves. And an F-curve contains all of the data for position, for location, for rotation. Each F-curve contains data for a specific property, right? So we have, in this case, since I use location, rotation, and scale in the other frames, we technically would have like at least 3 F-curves, which would correspond each to one for the location, one for the rotation, one for the scale, right? And each of those F-curves can have any number of frames. I could technically just save the location here, and I would now have an extra frame for the location rather than rotation and scale. And rotation and scale would have only 2 frames, which would be these 2 right here, right? So the system, the way it has been implemented, if we go over to the code, is that it first loops over, well, let me close my utilities. So we have a get action keyframes, right, which inputs an action from Blender's objects actions, right? And it iterates over every single F-curve. And as I explained here, it might look like it's a little bit non-performant because you're wasting a lot of time. Like, if every single F-curve is going to have the same amount of frames, then you're going to, waste time making a check that doesn't need to be made. But this is made so that it has support, because it's actually really fast to iterate over this, right? You will need to have billions of frames for this to even be slow. But basically, that way you make sure that you generate a frame for every single frame that exists, no matter what F-curve it is located in. And we store it in a set, right? So we're storing the keyframes.co0, which is basically the number of the keyframe. We don't care about anything else, and I'll explain why. Because when we go over here, so what we're doing here is go and check if the action is valid, and if it's valid, well, we have a set, and we go over all of the F-curves, and we start going ahead and going over every single keyframe on each F-curve, and we start adding them to this set, right? So we only add unique instances. So if we already have a keyframe, add keyframe number 15, for example, from one F-curve, we will not add it again. And after that, we sort it and we return it as a list, because sorted returns a list, right? So that's a Python thing. And in here, the rest of the code where we got the generate animation data, we basically go ahead, we pick the FPS, calculate the time per frame, and this is how we calculate the duration, taking the time per frame from the last frame, and then the time per frame times the first frame and subtracting it to get the total duration, right? And after that, we iterate over every single frame in the Blender keyframes which we obtained with this function, right? And we evaluate the location, rotation, scale at that specific time. So what we do is say, to be able to evaluate the scene, we use VPI context scene frame set. And this function right here, what it does is tell Blender to set the scene timeline to be at that specific frame. So we calculate all of the scene data for the animation data related to basically every single object, but Since we're not going to be able to do all of those in parallel due to the way it's programmed, we only compute it for one object, but whatever, right? It's fast enough. I would like to be able to have like all of the animated objects in a single list and be able to compute them with a single, like on every single set frame, but it's not going to be feasible because think about the fact that the animated objects have a tree structure, right? So I think it's going to be really hard to recode everything to make it work that way. I don't know. If anyone has more experience with the way Blender's Python API works, then they could probably make it in a better way, but this is what I've come up with so far. So we just iterate over every single frame, we update that scene to set it to that specific frame, and then we go ahead and just calculate the time of that frame, right? By getting the time per frame and multiplying it by, the Blender frame. And, recalculating time per frame is not too expensive. We do it once for every single animated object, which is a shame because it would be better if this would be a global value, but like, I don't know if there's a way to bake in the frame rate changing with some properties, right? Because in here, one of these panels, I don't remember which one, you can go to render, I think, and you can change the frame rate of the animation, right? It's somewhere in here. I'm not sure in which one of those panels, but there's an option to change your frame rate. And by default, I think it's 30 FPS or something like that, or maybe it's 24, I don't remember. But the frame rate we're working with right now, it's good enough for me, right? So basically this is going to be the animation that we're going to be making, and well, as I was explaining, basically just goes over it and computes the values of the position at the specific frames. So what we were doing is just in the set thingy that I showed before, we just get the numbers of every single frame in the timeline where there's animation data stored, and then we go over every single frame and we say, okay, well, give me the position, rotation, and scale that is relative to the parent, of course. That's what this transform is. We guarantee that the input transform to this function is relative always, and just compute that value. And now that we've got it computed, we store it in these tuples, and we go ahead and put it into a frame, and we store it within those frames, and we will organize it in the final JSON file later, right? So yeah, it's pretty cool. Now that we've got this thing though, let's go ahead and I said we were going to test something, and I don't remember what is it that we were going to test, but whatever. Let's just say that we got something like that now, right? And we go ahead and say location, rotation, and scale, and we can just go ahead and put it in here or whatever. We can have location, rotation, and scale. Whoops, I didn't mean to put it in the same frame. I meant to put it in here. Right, so this is a very ugly animation, very stupid if you think about it. Doesn't really make any sense. But like, I want to demonstrate that this thing can, work. And we're going to actually also change the scale of the object. We're gonna go like this. And I don't know if the scale works. I hope it does. But we're gonna do that. We're going to change the scale. We're gonna oh yeah, I remember the collisions. That's what we wanted to test. So I'm gonna make a platform, right? I'm gonna make it wait for a while so that you have some time to get aboard. And after that, we're going to move it upward here. Yeah. I think so, right? What did I do in here? Oh yeah, that's right. I'm a bit rusty with the way the timeline works in Blender, because it's been a long time since I last made any animation stuff, but yeah, it's all coming back to me. So basically, this is a very fucking stupid animation. It makes no sense at all. I don't like, well, I mean, I do like it, kinda, but like, it doesn't make any sense. It's not its purpose to make any sense. Its purpose is just to be a showcase for the fact that you can now make animated level parts that have like an elevator, like they can change scale, whatever. As I said before, I don't know if the scale change works, but the scale is stored in there, so technically it should, right? Like that's the expectation that we have. So yeah, we got this thing going, and we're going to go ahead and click has collision. We're gonna place it on generic. So I'm going to click the object. It also has collision enabled, so that's good. Let's go ahead and save and file and export the thing to a JSON file with the animation included. And if there's any errors or anything like that, well, look at that, 1.8 seconds, pretty quickly. So actually it's not that good, because the animation with just 2 frames was in 1.6 seconds. Oh yeah, but that's because of the prettified JSON file, because it's adding a few extra lines, I think. I don't know, we can check it out later. Actually, we can explore why it's been so slow, because adding a few extra keyframes, having so much extra downtime is not good. If we check this out, we can see that the generation time is actually 0.5 seconds. And if we went over here, it was 0.47 before. So yeah, it added a little bit of extra time on the generation stage, evaluating every single keyframe. But most of the time hog is in here, you know, in the JSON stuff. Although not really, to be honest, it's not even that much of a difference. I'll profile that because I am recording with OBS, so that could be affecting the performance as well. But anyway, if we go over here, we can see that our, well, let's close the model thing. We've got 8 frames. It lasts 2.916, almost 3 seconds, right? So if we go over here, we got those 8 frames, all of this data right here, and in the y-up coordinate system, and that's correct. The last frame has the exact time that it should have, and that's good. The only problem I'm seeing is that actually the moment the object reaches up here, it's going to finish the animation and the platform is going to disappear. Because I set it to loop, so I'll showcase that part of the code actually as well. I think it's in this file. So if we go over here, we got this thing. I'm going to move it over, right? And this is where I've got the XML file where we got the code to start the animation, right? And I said loop to true. So I'm going to go ahead and duplicate this thing. Where the fuck did my cursor go? I don't know what is going on, but anyway, it's kind of weird. I have this problem before. I don't know why it's fucking happening now. It usually happens when this thing keeps being open for so long that it starts to shit its pants. But yeah, we got the playing animation, and rather than saying loop through, we're gonna say loop false, and that should be it. We could add a delay of 0.5, for example, right? Or 1.0, I think. 1 second delay would be good enough to have enough time of reaction, right? So yeah, I'm gonna go ahead and compile the map and I'll be back. And well, of course, I said I was gonna go back, but I actually decided to record this part as well because some people might be curious how fast this is going to be. This is the compilation step, translating the JSON. It's done, it already finished, right? Like this is translate the JSON to XMB file. Like it takes this long because it's printing out to standard output in the console, right? If you set debug level to 0 and you don't print absolutely anything to the console, it's gonna be way faster because it doesn't have to waste time writing stuff to the console. But yeah, like literally it's just that fast to write the binary file. The most slowness that comes from, you know, the Blender side of the code is literally that the Blender API goes through Python. That's literally the only reason it's slow, right? So yeah, okay, so here we are again in Magicka. It's loading up, and there we go. Let's go ahead and start up the map, and hopefully it will not crash. I hope it doesn't crash. Alright, it didn't crash, which means I actually implemented this more or less correctly. So I'm not sure I'm going to have enough time to get to the platform, but like... Oh no! The scale is wrong! But it works. The scale works as well. The problem is that the scale is wrong. Ah, fuck. That is so sad, but that was so cool. Okay, I need to figure out how the scale works, but that was great because it means that we can scale up and down parts, right? Now, I'm not sure if we are like stuck to uniformly scaling stuff up. It seems like my scale on the Z-axis actually broke stuff. Not sure what went wrong there. Let me check. Alright, so as we can see, the scale, it's kind of weird. So let's go over here. You can see in the last frame that the scale is actually XYZ, right? And you know, Magicka's system is Y up. And for some reason, the X-axis is the one that is super tiny. The Y-axis is extremely large, and the Z-axis is weirdly large as well. That's wrong. That's clearly wrong. That's not the way things are meant to go. If we go over each and every single other one of the parts, we've got scale of 1.0. Well, this one is kind of weird, but it's because it's translating already. We only contain the location in this one, if I recall correctly. It's frame 3, right? Yeah. The third frame we showcased in the video only is storing location, so since it didn't fix the scale to 1.0 on every single axis, it started to scale up for the next one, I guess, or not really. Yeah, it's just lerping issues, which doesn't matter because this is practically 1.0, you know. But yeah, not entirely sure how I'm gonna be able to fix that because everything else is correct, you know. The rotation, the translation is all correct, it's all Y up, but for some reason the scale is not. So that's the problem right now. I'm gonna have to figure it out and I'll be right back. Alright, so okay, look at this. We got the bone right here, and if we try to scale it up around the Z-axis, it's weirdly scaling up well, around every axis, but the most fucked up thing is the fact that it's scaling along the X-axis, right? The X1 is scaling along the Y1, and the the Y1 is scaling along the Z-axis. So that's what went wrong, basically, because if we go over to the file, it actually kind of translates weirdly. You can see that it actually does not rotate anything. It keeps the scale just the same thing as it was before, right? Like 0, 11, 9, that's wrong, right? Like it should account for the rotation being in a Y-up system, but it did not. So I'm not entirely sure why that is the case, but it is what it is. If we go to the other objects though, this one is those are properly scaled and rotated, right? So yeah, it's not a problem with the transform probably, because everything else works just as intended. And this object itself, you know, if we go back to the frame 0, it's also actually scaled on its own, only that this component is, you know, the form in here without edit mode, so it's the vertex data itself that is changed. So yeah, I don't know exactly what is going on or why this thing is fucking up in here, but it probably has to do with the parents, because they were made for the old animation system, you know, and they could potentially be mucking up stuff. So I'm going to try to fetch this guy into the collection outside of any roots, and hopefully we can see what is going on now that it's in isolation, right? So yeah, alright, so I figured out the problem. Basically it's because the the transform matrix, when you translate it by rotating it into a y-up axis system, right, it doesn't actually translate to scales, right, because the scales are relative to the axis around which you scale. So if you think about it, the way that the scales are represented is not relative to any forward or local vectors in here. But judging by the way that it works in Magicka, it probably is relative. and that's kind of weird. I'm not entirely sure how it works, but we can figure it out eventually. So let me show you how it works now. So we go in game. Let me wait for OBS to catch up. We start up. Let me go down here. Oh, let me just get rid of this fucker. And let's get ready for the platform. Oh no, it cannot carry me! It went up too fast, but we did collide with it. But yeah, as you can see, it's kind of a slanted, right? For some reason. It's more like the scaling is working like shearing rather than, you know, actually scaling up. But it's there, kinda. I'm not entirely sure how it works yet. But probably the scale vector is not really, you know, it's again like the weird way that the orientation vector works by rotating a unitary vector. It probably works something like that in Magicka as well for some reason. So I'll have to tinker around further with it till we can allow scale to properly work. But yeah, for now we could actually like bake in a scale always to be 1, 1, 1, or we could just, you know, deal with it and say, hey, you can use the scaling of animated parts if you want, but user discretion advice, right? Like, it's your own fault if things break. Or you could always uniformly scale things up and down, and that would work just fine, because it seems that the scaling around a specific axis is where the problem comes into play. But like, maybe the scale, you know, like maybe the scale, rather than being applied first, in the case of Magicka's animated level parts, the scale is like applied sort of globally, like at the last step, which would mean that if we rotate this in diagonal, it would probably scale weirdly. We can test this one out just in case. Like, let me check it out first, because I have a hunch that probably if we do this, it's gonna be like not scaled up like this, right? It's going to be scaled up like in a diagonal way, right? You know what I mean? So it's gonna be really weirdly slanted. So that's probably going to be what happens. So let's see. Okay, we're back again trying it out, and we'll see what happens, but it's probably gonna be pretty severely fucked up. Let's check it out. Yeah, just as I thought. Just as I thought. Scale is not applied relative to the object's rotation. Like, the scaling of the object is kind of global for some reason. So that's really bad, because it means that if you want proper scaling, we are actually fucked up. Because, you know, the object was meant to be rotated like this, so we scale up along this diagonal, right? But instead, look at what just happened. So that means that the scaling factor is applied globally to the object, like some sort of, you know, as if we had a bounding box around it, and we scale it with, you know, the scale being applied aligned to the axis of the world, rather than being aligned to the axis of the object. And that's bad, really, really bad, because we can't really scale objects freely. Actually, we can only scale them, you know, jet. I mean, maybe I'm wrong, right? But from what I'm looking at my screen, on my screen right now, that's literally what I'm seeing, and it feels to me like the scales are around the axis aligned boundaries of the world, right? So that would mean that to be able to get proper scaling, we are going to have to scale everything uniformly, and we can't really scale things the way that I wanted to scale them. So that's bad, really sad. It's actually pretty sad, because we can't rotate the scaled objects unless they are planes, right? And only planes if they are scaled like uniformly, right? And even then, I think we would have some problems. So that's bad. That's really sad, actually. I'm kind of sad about that. But it makes sense, because there's nothing like getting scaled up in a non-uniformly way in the game, right? Like, whenever we see something getting scaled up and down in the game, it always scales uniformly, so it makes sense, right? It's basically that the scales are sort to be along the world axis rather than the local axis of the object, and that is not something that I like. But if you think about it, even if that's not something that we like, it kind of makes sense from a certain point of view, because the bone technically only stores a scale, right? It doesn't necessarily store an orientation. It stores a rotation, right? But not something that says how the scale is to be applied. So yeah, there's no, like, unless internally it would calculate some relative vectors like the forward vector, right vector, and up vectors, it would be basically impossible. So that's sad, and it looks like it doesn't calculate them clearly from what we're seeing. But at least we know we can uniformly scale objects, right? And that's good. That's still pretty good, but it's not as good as it would have been if we could scale objects freely, right? But yeah, I'm gonna keep it in, right, in case anyone finds any trippy and cool effects that you can do. Like, we could probably do something cool, like, for example, having this object rotating in circles, right, while it's scaling pretty weirdly. It would probably look pretty cool, but like, it's most likely going to have zero fucking practical applications, so that's sad. But yeah, whatever, I tried. But yeah, it's still a pretty good result so far, because this is as far as we have probably been able to take things, and that means we can now make interactable objects. We can now make pretty much anything, right? And yeah, that's the next thing I would like to try out, making an interactable object.